Hey everyone, a very warm welcome and good evening to all of you for joining in our series of masterclasses and in today's masterclass. So we have Soumya Mishra over here with us. So Soumya is an software engineer, is working as a software engineer at Microsoft. She has over 5 years of experience in the software domain, software development domain. And the topic that we will be discussing in today's masterclass is quite exciting. It's about Google Maps, like the how Google Maps started, the history of Google Maps, and how Google Maps never fails to give us a lightning fast ETA on how would we cover the accurate ETA on the distances that we put in over there. And many more things, many more features that Google Maps has, and how Google Maps is built, and the experience that we have, the seamless experience that we have, how it is able to be accurate at every search that we put. So Soumya, over to you.
Hello. Thank you, Rashmi.
Yeah.
Okay. So thanks for that introduction. Welcome everybody. Very warm welcome to today's session. And as Rashmi already pointed out, that today's session is going to be about and around Google Maps. Okay. So we are going to deal with everything that Rashmi already said. And in addition to that, we'll also see the system design of it. Okay. So although the system design that I'll tell will be very specific to Google Maps, okay, but that can be extended to any navigation service or any navigation app that you would be creating. And before that, we'll also talk a little bit about system design, trying to understand what is it, why is it needed, and everything. All right. Okay. Now, before we begin, can I have a quick show on the chat of how many of you have used Google Maps? Or let's say, is there anybody who does not know anything about Google Maps? Ki matlab, use ही नहीं किया कभी. I hope everybody knows. Everybody knows what we are talking about. Google Map, everybody has used, right? Yes, of course, Abhishek, you will be able to understand. So what I will try is that to make this session a mix of, technical and non-technical, so that people from both the backgrounds can grasp what is being taught. Okay. All right. So from the responses that I am seeing, I see a lot of you have used Google Maps. Now, the second question that I have is that if I ask you to rate yourself in system design, okay, out of say like from 1 to 5, 1 being lowest, 5 being highest, how much would you rate yourself? Okay. All right. Okay. So we got a variety of answers ranging from 0 to 4. That's nice. That's going to be very interesting. Okay, so let's get started with today's session. Just a second, actually, I just want to, let me just share the correct screen. Right. Actually, I'm seeing a way to just share one window. Yeah, I guess this works. All right, can you guys confirm if you can see my screen? I hope everybody can see my screen over here. All right. So let's get started. This is what today's agenda is going to look like. First, we are going to talk about overview of Google Maps. Okay, this I will not talk a lot about because majority of you have already used it. Okay, then we'll talk a little bit about history of Google Maps. all this is theory. Okay, we'll talk about Google Map features. Then we'll come to system design and its importance. This will be generic. Okay, what is generically system design? What is its importance and all that. Then we'll talk about elements of system design. Okay, what all comes into system design. Then we'll delve into the system design of Google Maps. We'll see the technologies that are being used in building the Google Maps. Okay, and then there's going to be a quiz in the end. So all of you, please pay a lot of attention. Okay. And at any point, if you do not understand anything, if you want me to repeat something, feel free to let me know. Okay. And yeah, let's get started. So talking about with overview of Google Maps. So Google Map is nothing but it is a application, okay, which uses a lot of services like navigation service and a lot of location service, a lot of those service to tell you, say, the route between point A to point B, okay, to point in the world. And Google, you can use Google Map to find the routes in that. And it gives you information like, what is the traffic, what is the expected ETA and all of that. Okay, so that's what is the overview of Google Map. Nothing much to talk about it. Let's come to history of Google Map. How did this entire thing get started? All right. So in 2004, Google had, so all of the textual matter is written over here. I think that these details will be, the PPT will be shared with you. I'm not sure, maybe Rashmi can confirm. So the theory over here, not very important, but yeah, just for the sake of it, let's go through it. So in 2004, Google acquired a few, for companies, and it laid the foundation of developing Google Maps. Okay. Then what happened in 2005, Map was launched. Okay. And it was just a desktop web app. Okay. And then in 2007, the first mobile app of Map was launched. And then in 2015, as it is mentioned over here in the timeline, offline map support was given. And, in which you could use maps without having internet connection. In 2019, Live View was introduced. Okay. They used augmented reality for, to help you with navigation and exploration and all that. Okay. So this is what is the history of Google Map. This is, so if you see, Google Map is not a very old product. It is nearly like, say, 20 years old. Okay. So yeah, that is what is the history of Google Maps. Okay. Any question till here? And please do not spend time in, copying things down or anything like that. The team just confirmed that the PPT will be shared with you. So all this data is already going to be with you. Okay. Over here, just try to understand it conceptually. What is system design? Okay. How can you go about it? All right. And when it comes to system design, there is no like one right answer. Okay. I am designing a system in X way. You could do it in Y way. Okay. That's totally up to you. All right. So coming back, features of Google Maps. Okay. So a lot of you already know the features of Google Maps. What are the features that you have used? Let's hear from you. Instead of going through this deck, you tell me what features have you used? Correct. Direction, live view, okay, satellite view, right? Navigation. Right. So one of the features that I have used most, so I'm from Bangalore, okay, it's famous for its traffic. So the one of the feature that I have used most is this real-time traffic, okay? So whenever I have to go somewhere, before going, I'll just check that how's the traffic like, okay? Is it too crowded, like bahut zyada traffic hai ya nahi hai, and all of that, okay? So this is one feature that I have used. And like I've used all, but this is one that I use very often, okay? And yeah, these other features also, I don't think so that an explanation is needed. But yeah, these are some of the features that Google Map offers. So it will give you street views. Okay. You can also have indoor map. Okay. 3D map is also there now available. And satellite image is there. Real-time traffic is there. That in which route, how much is the traffic, what is the delay that is introduced because of the traffic. All those real-time data is there. Then location history is there, right? I'm not sure how many of you get those notifications. This is your March timeline. And once you click on that, it will give you all the places, like, it will show all the places that you have been to. Has anybody seen that? The location timeline, right? they give you like, this is your March timeline, this is your February's timeline, right? So that is nothing but location history. So basically Google Map stores all the location. Okay, so your location every time is being stored. So what is location? It's nothing but latitude and longitude, right? The entire Earth is divided into latitudes and longitudes. So location history is nothing but saving your location, and location is nothing but your coordinate at which point on Earth you are at any given point of time. Okay, so that is location history. Then route planning. Okay, this feature is also there. This also I very often use. Voice guidance is also there, very handy when you're driving a two-wheeler or anything like that. Okay, so yeah, these are some of the features which are there with Google Maps. Okay, now let's move to this system design. All right, now system design is extremely important. Okay, if you interview for companies like Google, Microsoft, Amazon, okay, or any good companies, actually nowadays, most like 99% of the companies ask system design. Okay, so if you are a fresher, very basic of system design is going to be asked. As in when you progress to a more a senior level, more intricate and detailed system design is asked. So system design has become a very integral part of the interview process, and it is again very important. So yeah, let's just dive into it. Okay, so talking about system design, first let us try to understand what is system. Okay, guys, do not see whatever is written over here. Okay, we'll just talk like this. Okay, just in casual, just casual way. What do you understand by system? When you hear the term system design, what do you understand by system? What do you understand by system? Okay, a process. And others, I want more answers. Let's make it very interactive. Okay, protocol. What about the others? Structure. Okay, okay. Awesome answers, folks. Very good answers. So, yeah, actually, it's a mixture of all the answers that we have got. Okay. A system is nothing but, if I tell you in a very layman term, okay, the Uber app that you are using to book a cab, okay, that is a system, right? What is a system? It is just having some input, okay, some processing is happening, it's going to give you some output. That is just one system. It is having a lot of components. So say, for example, Uber, okay, or Zomato. Zomato is having a lot of components, say that is one system, okay? So this is what is a system, okay? And giving you some hint on the type of interview questions that come. So say they will tell you ki design a messenger. Okay, so say you can design a messenger like WhatsApp or the Facebook Messenger, anything like that. Okay, so they call it a system. Think of a system like one app. Okay, not necessarily web app, mobile app, not like that. Just app in general. Okay, one entire system. There are a lot of components interacting with each other. All right, and yeah, this is what is a system. Is there anybody who does not understand what is a system? I'll read out the definition also over here. A system is a group of interconnected components, okay, working together to achieve a common purpose. So for example, I was giving you the example of Zomato. Okay, Zomato is a system, right? It is a system of a lot of components. So it has that navigation component also, right? It has that map component. Okay, in that map you see, right, where is your delivery person? That is one component. The another component could be the entire component that is taking care of the payment thing, like calling the payment gateway, and then payment gateway making sure that the payment is done, getting a confirmation, confirming the order, things like that. Okay, there could be another component which is taking data of the restaurants, right? So say, what is the average cost of a restaurant like? What is the current rating of a restaurant like? So Zomato as a whole is a very big system. Inside that, there are different components. All the components are talking to each other to, give a seamless flow to the user. Does that make sense? Yes, Rajdi, very good. Like updating the cart, deleting the items in your cart, right? everything is one component. Every component is responsible for what they are doing. Okay. And yeah, this is what is a system. Okay. So over here, example of system is there, Amazon, like e-commerce platforms, right? Amazon, Flipkart, right? Booking platforms like Uber and Ola, digital payment wallets like Google Pay, Phone Pay, all of this. Okay. This is what is a system. Okay. Now, what is system design? Can you tell me out of this? Now, you know what is a system. Now, you tell me what is a system design. What is system design? Okay. All right. Let's put it this way that we have already understood what is a system. Okay. So system design is nothing but designing that system. Okay. So say you understood how Zomato is like, okay, the app Zomato is like. So designing an app like Zomato or doing a system design of Zomato is nothing but designing the entire architecture of the application, identifying the components in the system that you are designing, okay, identifying things like how data is being stored, where data is being stored, when data is being stored, what data is being stored, you know, a lot of these questions. Is it clear what is system design? Okay. Now, whatever I'll be teaching you over here, whatever I will be telling, I will be mapping it back to how it happens in interviews. Okay. So in interview, say you will get, like I was telling, you will get a question like design a messenger application. That is what you will get. Okay. Now these system design interviews are very open-ended. Okay. It depends on you and your interviewer on how do you want to take it, which route do you want to take it. All right. So see, unlike coding interviews, okay. So say when you give a coding interview, the interviewer will give you a question and the interviewer will have, say, a rough idea of the algorithm that you might be using. Okay. That is also not 100% sure that you will use that algorithm only. But the interviewer has some idea of how the answer is going to look like, or even you have some idea of how the answer, how the entire interview is going to turn out like, right? All of you relate to what I'm telling? So coding interviews are like that. Okay. When I am the interviewer, I'm coming with a question. Okay. When I prepare a question, I also prepare an answer along with that. Okay. And but system design interviews are very different from these coding interviews. Okay. They are very, very different. So in system design interview, I'll just come up with a question. If I'm taking your interview, I'll just come up with that question, and the design that we make in the end of this interview, that could be totally different from what I would have had in mind. Okay. And yet it could be 100% correct. All right. So whenever in an interview, a question is given of system design, it is really open-ended. A lot of times it is ambiguous. Okay. It is not clear. So for example, I tell you that design messenger application. What do you think? Is this much data sufficient for you to do that? I tell you that design messenger application. No, right? This much data is not sufficient for you to do, design that. So when it happens with system design, a very big pitfall in system design interview is that people do not ask back questions. Okay. Like you do not ask clarifying questions. That is one of the biggest platform. Okay. So say you tell me that design messenger application. So some of my questions could be that, what is your targeted audience? Okay. Who is your target audience? Say you want to design a messenger, you want to create a messenger application for extremely elderly people. Okay. So the things that will be there in a messenger application, which is specifically designed for elderly people, will be very difficult. Which will be very different from what, say, you design for teenagers. Okay. So for teenagers, you will need extra layer of security. You will need extra layer of protection. You will need extra layer of, say, filtering of what content can go to them, or like just in general, okay, I'm just talking generally. And when you design for a senior citizen, okay, or the elderly people, so you will think about making the design very intuitive, making things very simple, not adding a lot of features, okay, making it minimal so that they can understand it very well. Yeah, Rajdeep, yeah, like mandatory good morning texts, okay. So this could be my question, okay, if you ask me to design messenger, that who is your target audience, okay, that you are targeting, or how many users does the system, like, the system that I am creating, how many users should it cater to, okay, how many users should it serve, or what is the average request that you are expecting to get, how much request should we cater, or things like, say, what is the request response time that you are expecting, okay. So these are some of the questions. I'm just giving you some of them, okay. There could be a lot more clarifying questions. What I want you to tell is that once you get a question in system design, in interview, or otherwise also, it's not final and it's not ultimate, okay. Say it's just 20% of the actual question. So it's very important for you to get the clarity in that, all right. So that brings me to the next thing that, okay, we'll come to it later. First, I want to talk about this, okay, steps to follow to a system design. Like when you are designing a system, what are the steps that you need to follow, okay? So this thing that I was telling, understanding the requirement, that is very important, okay? Now, let's take this example only, Messenger. So I gave you few examples. What are some of the examples that you could give me? If I ask you to design Messenger, what is something that you will ask me? Like, what all information will you need from me? Quickly in the chat. Okay. All right. These are the questions. Like, what questions will you want to be addressed before you start designing? A very good, Santosh. Text only, or it is a video message also, right? Very good. Very good. Group messaging. Very good, right? I want more answers. I want answers from everybody. Very good. Again, permanent chats, or are there going to be disappearing chats? Depending on if they say permanent chat, so you will need a more persistent database. If the chat does not need to be permanent, you can, opt for faster databases, which are not very persistent, okay? All right. Very, very good. Very good questions that you guys are asking. More. What are the more clarifying things that you will ask? Admin rights. Very good. Okay, so with this, I guess now you guys get a hinge of what do I mean by understanding the requirements, right? So if you go to an interview and they ask you to design Messenger, and considering the questions that you ask, okay, you're definitely going to make a very great impression. Okay, the questions that are popping up over here in the chat, you're definitely going to make a very great impression. All right. So say 20% of your work is done like that only. So see, it's very important to understand that understanding the requirement is the most important thing when it comes to system design. All right. If you do not understand the requirement properly, if the requirement is not clear, maybe the solution that you will build will not be what the interviewer would be expecting, okay? Or maybe the solution that you will build will not solve the problem that the interviewer expects to solve, right? So that is why this is the first thing, okay? Understand requirement. This is the topmost thing. Even if you do not do anything which has been mentioned over here, this is the most important thing that you absolutely, absolutely have to do. All right. This next thing is that identify the major component. Okay. So the thing is, like, you will identify. So just like I was giving for Zomato, okay? So one major component would be the entire payment service that will be there, okay? Another major component would be the component that is responsible for collecting restaurant data, okay? Another one would be for generating offers. Another one would be like so on, okay? Now you give me, what could be different components over here? Say we want to design Zomato. Yes, maps could be one of them, so that you can track your delivery person. Okay, list of restaurants, yeah. Location rating. Correct. Calling system. Yes, very good. Feedback portal. Correct. Right. So the next step is that once you are clear with the entire or all the requirements, okay, then you have to identify the major components of your system. What is going to be the major component? Once you have identified the major component, you need to identify the interaction or the relation between those components, okay? So say there could be components which are not connected to each other, okay? There could be components which are directly connected to each other. There could be components which are indirectly connected to each other, okay? Or there could be components which are say indirectly, not indirectly, but out of what do you say, inversely proportional to each other, okay? Like that. Like that could be the kind of relationship. There could be any type of relationship, okay? So once you're clear with the requirement, once you're clear with the problem, the next thing that you have to do is that you need to identify the components and identify what relationship will be among those components, okay? Tushar, okay, very good. So very good question. What could be the major component in the messenger? Okay. So say one major component could be the entire component who is restricting you to message the people who are only your friends, okay? Or a component which is taking care of who you can message. So say you add a new person to that, new person to your list. So now you can message that person also. And for Messenger, another component could be taking care of authorization, okay? So I cannot log in using your account and send messages in your name, right? So there could be a authorization authentication component. There could be like authorization authentication different, okay? Not one. There's a lot of difference between it. Do not use it interchangeably. There could be that, and say there could be a component which is taking care of making sure that unwanted people are not messaging you, the entire making a security structure and all that, okay? So these are some of the components that I could just think of, okay? Okay, now next thing is that choose appropriate technology, okay? Now, when you talk about technology, it is both hardware and software. So just giving you some example. Also, folks who are from non-technical background, please feel free to let me know when I go way too technical and you're not able to understand things, okay? So I'll tone it down. So hardware is the things that you can touch of a system, right? So for example, I'm sure all of you would have, like in junior classes, you would have read about computer hardware, computer software, right? What was the basic definition that we read? That everything that is tangible is hardware. Your monitor, your CPU, the mouse, the keyboard, all of that, right? All of that is non-tangible. That is your software. Like say the Microsoft Word application in your system, or the calculator application, the clock, all of those are software, okay? So a lot of things that you need to identify, what appropriate technology will you be using? So for example, hardware, okay? Let's take a very small example of hardware. Say you want data to be accessed very fast, okay? Like you want data to be available instantly, but you do not want it to be persisted forever. In that case, maybe you could use a flash drive for storing your data, okay? Just giving a very vague example over here, not related to Google Maps design, okay? Just giving a very vague example. Or another thing could be, say, software choices. So for example, the app that you are building, okay? So is it going to be a single page application? Is it going to be a multi-page application? Which technology should you use? Should you use React? Should you use Angular? Should you use HTML, CSS? Should you use other frameworks that are there, libraries, Bootstrap, Vue.js? A lot of these things are there, right? So that also you have to choose. Now, how do you choose? Depending on what is your requirement. Okay. So for example, let's take the example of React. Okay. React is very great with reacting, right? So if there is you're making an application for which the data is very frequently going to change. And for that, you do not want the entire application to be reloaded. All right. So all of you have seen Facebook, right? So in Facebook, what happens is that you get a center screen with news feeds and everything. And on the right hand side, there is a scroll kind of thing where you see all the people who are online. Have you seen this? Right? And it keeps changing. Do you see it keeps changing? Say somebody new came in online, somebody went offline, it keeps changing. But when that component changes, does your entire page reload? Say one person came online and then your entire page reloads, right? That is not how it happens. Why? Because it uses a technology like React. Okay. It uses a technology like React. Now, that is going to update only that part, only that node which is changing. Okay. Only that thing is going to be updated. The entire node structure is not going to be updated, right? So say if you want to create a UI or an app in which the state of the app is going to change very often. And because of that, you do not want it to change, you do not want that to change the entire application, or you do not want your entire application to be reloaded, right? So in that case, maybe I'll go with React, or I'm not telling, so see, there's not this just one technology which is best, which can be used everywhere, SNAM, right? It depends on what you're trying to solve, what your system demands, okay? So depending on that, you will choose the appropriate technology, okay? What is the appropriate technology? Which technology will work for you? Similar for databases, right? So for example, if you're storing large amount of data, you will go ahead with a NoSQL data, right? In which you can store it in a document way. If you're using small, like if you want to store small amount of data, you can go ahead with a SQL kind of database, all right? At this point clear, what do I mean by choosing appropriate technology? Okay. Now, the next thing is that you have to define interfaces, okay? By interface, I mean like what APIs are you going to have? What data the API is going to return, okay? What are the rules? What are the protocols that your application or your system is going to use? And what is the format of data which is being, which the components will use to communicate? Say there is component A. Component A is sending data in string, but the receiving component wants it to be in JSON, okay? Or the receiving components wants it to be in some other format. That will create a ambiguity, that will create an anomaly, okay? And your system will break, right? So this is also very important that you define your interfaces, okay? Now, the next thing is that you have to design the data model, okay? Now, again, this is very important. You have to create your database schema. What is meant by schema? Basically, in very simple term, what all are you going to store, okay? So say you want to store some student data. So schema mein kya aa jayega? The roll number of the student, the name of the student, the class of the student, the section of the student, the subject opted by the student, the emergency contact of the student, right? These things will come in a database or in a table where you want to store student information, right? That is what is schema. What all things do you want to store, and what is the type of data that you want to store, okay? That is basically schema. So designing data model means just this, that you are you're creating your database, you're creating your tables, or not like technically creating it, but at least designing it, that how is your database going to look like? What all tables are going to be there? What are the columns that are going to be in that table? What are the properties that are going to be stored? Data flow, how is data going to flow from one system to another system and all that, okay? Another point is that you also have to consider scalability and performance, okay? So for this, let's take an example of Netflix. Okay. So long back, Netflix was hosted in its own cloud. Okay. Netflix was running in its own cloud, like long back. Okay. So say, I guess 2005, 2006 at that time. Okay. Then what happened in around 2006 and 2007 that suddenly Netflix gained a lot of popularity. Okay. And because Netflix gained a lot of popularity, it suddenly had a lot of users using the application. Now, what did it do? Can anybody guess? Suddenly, think of it like suddenly Netflix became viral, okay, in 2006, 2007. And because of that, a lot of people started using Netflix. So what was the impact on Netflix? I'll tell you what it was, but what do you think? Very good. What about the others? Like, I want answers from all of you. Okay, okay. Any more answers? Correct. So actually what happened in 2000, then, okay, I do not remember, was it 2006, 2007, but whatever, okay, let's say X. So in that year, what happened? Suddenly, Netflix gained a lot of popularity, which attracted a lot of users. So the usage of Netflix increased incredibly. And Netflix was not ready for that. Okay, Netflix was not ready for that, for scaling up that fast. And it resulted in Netflix crashing. Okay, Netflix was down for a lot of hours. And you can imagine the revenue loss that Netflix would have faced. Okay. So after this, what happened is that Netflix said, ki, theek hai, we won't be doing this anymore. We won't be able to manage and we won't be able to scale up and down according to the user base. So Netflix decided to go with AWS. Okay. And till now, Netflix has been deployed on AWS. And at least I have never seen a downtime of Netflix. Okay. So what AWS basically does is that it does a scaling. Okay. So say if your application gets more users, so it will spawn more new instances of your application. There will be more pods serving your application. And you will be charged more. If suddenly your user base drops, okay, suddenly the user of your application drops. So in that case, the pods which were there or the instances of your application which was there, that is going to be reduced, and ultimately your cost is also going to be reduced. So for things like AWS, you're basically just paying for what you're using. Okay, so this is also one aspect that you need to understand about scalability, that how do you want to scale your system. And so for example, see, Netflix initially did not apprehend how much scalability Netflix will have to do, right? Right. Initially, Netflix was not able to apprehend this, right? And because of this, Netflix faced this downtime. So that is why a good system design involves that you consider the scalability aspect of it, right? How do you want to scale up? And are you ready to scale up, right? Considering all of those things. Then again, load balancing is there. So all of this comes under performance, okay? So say for your application, you are running 5 servers, all right? And you're getting 100 requests. Now, there are 2 scenarios. Now listen to this very carefully. I am telling that your application is having 5 servers. Okay, your application is running on 5 server and you are having 100 requests. Now, in scenario 1, what you are doing is that all the 100 requests you are sending to one server. In scenario 2, what you're doing is that first 20 you are sending to server 1, next 20 you are sending to server 2, and so on. Okay, 20 you are dividing. Now, what do you think performance will be better in which case? Scenario A or scenario B? Right, of course, scenario B, right? That is called load balancing. Okay, that is what is load balancing. You'll hear this term very often. Basically, whatever is the load, you divide it among your servers so that the entire load is balanced and none of the server is being overloaded. Okay, so all of those things you need to take care when you're doing system design, that how do you want to, like, address these load balancing concerns. Then another thing is caching, right? So what is caching? So cache is a small memory which can be accessed much faster than your main memory. Okay, so in performance, what we do is that, so say some data which is very frequently accessed, we put it in cache. Okay, because it is being frequently accessed, so user will get that response, like user will request for that very frequently, and if it is there in cache, it will be provided very quickly. Okay, so all of these help in building performance. This is not an extensive list when it comes to performance. There are a lot more things that you need to consider, but this is a good starting point. Okay, all right. This one. Now, the next thing is that testing and validating. Okay, that is also, of course, very important. I don't think so I need to elaborate on testing and validating design, but you tell me. You tell me about testing and validating. What do you feel about it? Yes, correct, Rajdeep. Very good, Arindam, right? It's very important that whatever design you have created, okay, you do a trial of that. You do a dry run of that design with real data, the real data that you're expecting your system to operate in. Okay, so that is very important. That is also a part of system design. And another part is deployment and maintenance. Okay, that system to tumne bana liya. Now, where are you going to deploy it, right? So are you deploying it on your own? Like, are you doing in-house deployment like Netflix had done before? Or are you using any cloud provider services like AWS, Google Cloud, or Azure? All right. So these are also some things that you need to take care of. All right. Clear steps to follow when you're doing a system design. A very good question, Rishabh, that for deployment, how can we make a decision at such an early stage, right? It's very difficult to make a decision at an early stage. That is what Netflix did, right? It made a decision at a very early stage, and that decision ended up being wrong. Okay. That is why people use these web services, right? These cloud services like AWS. So in AWS, you do not have to make any decision. You do not have to tell ki, I would be needing, say, these many resources. You do not have to do that. You just deploy your application on AWS, and AWS is going to take care of scaling up and scaling down as and when the requirement of your application increases or decreases. Does that answer your question, Rishabh? Okay. All right. Now let's come to it. Okay. Importance of system design. Now, importance of system design. See, first, it is very important that like the major importance is that to meet the specific requirement. Okay, whatever is the requirement that you can meet if you're designing your system properly. Okay, system design helps you with that. Now, it helps you optimize resources. How does it help you optimize resource? Because you are planning things. Okay, you are designing your system. You are seeing कि ठीक है ये component हो गया, वो component हो गया. How much am I expecting here? How much am I expecting here? So everything you are doing in a planned manner. Okay, if you do not do system design, you will just be on the flow, right? कि चलो अभी ये बना दिया, अभी ये बना दिया, right? That will lead to a lot of wastage of resources, right? So system design helps you with that, optimizing the resources, right? It helps you with it helps you to ensure interoperability. What it means is that a lot of components can come together and work together. Okay, that is possible because of system design. Okay, that system design helps you with that because you are designing your system keeping those things in mind, right? It reduces risk, right? How does it reduce risk? Because when you design a system, right, so you need to think of like plan B also. So when you are giving a design, so the interviewer can ask you that, okay, if this memory fails, what is going to happen? So you need to think of that. You need to think of backup. all right, if this, so say if your main memory fails, something happens, you must have something in the cache, okay? Or say some secondary memory from where you can go and fetch things, all right? So when you do system design, you get clarity on these things, okay? You get to answer a lot of these questions, you get all of these questions, okay? And that is why it helps you reduce risk. And another is facilitate maintenance and upgrade, okay? So because when you design a system and you're trying to make it scalable, right? So definitely that will help you a lot in, maintaining the system, scaling it up and down and all of that, all right? So till here, whatever we did was very basic or very, what to say, generic concepts of system design. Any questions till here? Yes, Deepraj, it is included. Any questions, guys? Yes, Ujjwal, as I already mentioned, you will be getting the PPT. A very good question again, Rishabh. I will not dive very deep into it, okay, because it is very much specific to AWS, all right, and this class is not about it, but I'll just answer it in a very high level. So AWS is not expensive when it comes to long run, okay, because say you are expecting that once your application becomes a hit, you will have 1 million users, okay? So that is what you're expecting. Now, what happens is that initially your application will not have 1 million users, right? Will it have? Yes or no? What do you think? No, right? Initially, it's not going to have. So will you be, so if you do not use platforms like AWS, okay, which can help you scale up and scale down. So Shurvat se you will have to make that interface, right? From starting, you will need that interface. And theek hai, when that need comes, so that will be fulfilled and you do not have to pay any service fee to any service provider. But then till the time that need doesn't come, okay, that thing is being wasted. And also, like, for example, say that need never comes. You never reach that mark which you decided. It's all wastage, right? But when it comes to AWS, you're basically just paying for what you are using. Okay, so it's not it's not expensive at all. It's just that say you are having a function at your house, right? Say you have a wedding. You are inviting 500 people to your wedding. Now, say the day you are born, your parents know that most likely you're going to be married, right? So they won't build a house that can have 400 people all at once. They won't do that, right? Or even you won't do that. What you will do is, or what they'll do is that when the wedding is there, at that time they'll go and they'll book the venue which can accommodate 400 people, right? Just because you're expecting 400 people at some point in time, you will not arrange for it, right? So yeah, it's the same analogy here. I hope that answers your question. All right. So this was about it. Okay. Now let's talk about elements of system design. There are two types of system design which we do. Let me come over here. Let me write just a second. Okay. All right. I just a second. Yeah. So we have high-level system design and low-level system design. Okay. Or let me just say low level. First, I'll talk about high level and then we'll move to low level. All right. So in high level, whatever system you design, okay, whatever system you are designing, all the systems can be roughly divided into three three components. Let's call it component. Okay. So say whatever system you are designing, it will have first component or first layer, application layer. So this is going to be your application, right? Through this, the user is going to interact with your system. This is your application layer. This is one part. This is the another part which will be called business logic layer. Okay. So all your business logic, the code that you have, the concepts that you have, all of that is going to come over here. Clear? Ye dono layer clear? Okay, cool. Now, the third layer is called a persistence layer. So this will be your database layer. Okay, jahan pe data is going to be persisted. Now, when you go to an interview and you have, like, you need to tell, like, they ask you to do a high level design of any system. This is what majorly you will cater to. Okay, कि ठीक है, application layer में क्या आएगा, and the business logic layer में क्या आएगा, persistence layer में क्या आएगा, right? These are some of the things that you're going to cater to. Now, say persistence layer में, just giving an example, okay, that how are you going to store data? Now, your memory cannot have infinite data storage, right? Infinite to data नहीं store कर सकते. There is a limit on the amount of data that can be stored, right? So in persistence layer, there could be questions like, what could be the evacuation strategy? How do you understand when do you want to remove something from the memory? Okay, things like that. So high level design, this is what high level design means. Like the entire system, you're breaking it into three. It could be more parts, okay, but this is the most basic. It's good for entry level. This is sufficient for entry level. And yeah, so basically in high level design, you are dividing your entire application into three segments, and then you take up one segment and then you see how, and then you tell how that segment is going to behave like. Clear about what is high level design? Sure, Anirudh. Persistence layer is nothing but your data storage layer. How do you want to store your data? Is it going to be a NoSQL database? Is it going to be a SQL database? How is the evacuation strategy going to be? When are you going to remove data from your database? All of those things, okay? Clear? Yeah, sure, Arjun. This application layer is the actual app, okay, with which the user will be interacting with your application. The user interaction is captured in application layer. The middle is the business logic layer, in which you are going to write the actual code. Key, if this is happening, how is the system going to behave? What is going to happen? Clear? And persistence layer is your data storage layer. Clear till here? Okay. Now, this is what is high level design. Okay, identifying these things. Now, when you talk about low level design, okay, now a disclaimer for people who come from non-technical background, this might be something that you may not very clearly understand, okay, but I do not have proper words to explain it. So low level design, what happens is that you are going to identify that what all classes, okay, will be there, what all entities are going to be, entities, components, whatever components are going to be. You're going to make your classes, okay, ki class kya kya hoga, what will be the property in that class, what will be the function of that class, or say what will be a property of a component, what will be the relationship between two components, right? So for example, if I tell you Zomato ka lete hain, right? So one is order placement ka component, and another is payment wala component, right? So these could be two components, okay? So say this is using some other payment gateway, right? A third party payment gateway, a pay you money or anything. It's using anything, right? And So what happens is that order placement will talk to the payment component. Okay. Once this payment component gets a confirmation from the payment gateway and everything is sorted, so it will tell this order placement, it will inform the order placement component and the order will be placed accordingly. Okay. Clear? This is what is low level design. Identifying the components, okay, identifying the entities, the classes that you would be having, the properties that those classes can have, the function that that component or class can do. Is that making sense? Okay. So this is what is high level design and low level design. We'll just quickly go through these terminologies which are mentioned over here. Okay, and that will maybe help you understand things better. So see, high level design kya hai? Designing the system's main component or modules, right? You're designing that. Establishing the relationship and dependencies between the components. Identifying the primary data flow and control flows. Determining the system's scalability, reliability, maintainability. Okay, doing everything on a very high level. Creating high level diagrams such as context diagram, system architecture diagram, and all that. Okay, there is data flow diagram, a lot of those things. Okay, not important right now. That is way too technical. Now, what is low level? It's defining the internal structure, right? Designing the algorithm. How is your algorithm going to look like? What data structure do you want to use, right? Specifying error handling. How error handling is going to be done, right? Input validation, like very low level things, right? Very like intricate things. Creating detailed design document, flow chart, transition, everything, ensuring the component adhere to coding standard guidelines and all of that. Is it clear? So see, this high level system design is more like a bigger picture. Okay? On a bigger picture, how is your system going to look like? Low level design is delving inside that bigger picture and finding out or identifying the different components that you would be having, the different things that you would be having over there. Yes, Gauransh. One needs to design both. Okay, you have to do both high level and low level design to come with, to come up with complete system design. Okay. Now, let's take quick 10-minute break over here. Let's meet sharp at 9:10, or I guess we can meet at 9:05 also. Let's take a 5-minute break. Let's meet sharp at 9:05, and then we will start with the system design, which will be very specific to Google Maps. Okay. All right. Okay. Okay. All right, folks. I hope you guys are back. I hope everybody's back. Okay, great. Let's get started. Let me share my screen again. Now, what we are going to talk about is very specific to Google Maps. Okay. And to be honest, the same thing can be extended to any navigation service kind of app that you would be creating. The same thing will be extended there. All right. Now, whenever you are designing any system for that matter, okay, you need to understand two things. Like actually, you need to figure out two things, that what are going to be your functional requirements, what are going to be your non-functional requirements. All right. So when I say functional requirement, it means like what are some of the features that your app is going to have. Okay. So for example, if we talk about any mapping feature, okay, or any mapping application, Google Map, let's take Google Map only. So what are some of the features that you will expect Google Map to have? So if I tell you ki there's a app like Google Map, what are the features that you will expect? Okay. Okay, good. Right. So say whenever I talk about Google Maps, okay. So very first thing that I would want is that it tells me the route between point A and point B. Okay, say there are 2 points on Earth, point A and point B. So I would expect an application like that to tell me the routes. Okay, what is the route going to be between the 2 points, right? That is one. Also, we are going ahead with very basic features over here. All right, the functional requirement can be extended, right? However you want your application to behave. So identifying the routes, finding the road, mentioning the road between any two given point A and B. That is one feature that we definitely want to have. That is one of the functional requirement. Another requirement is say ETA. Okay. So I have put a point A and point B, and I should be able to know the ETA between those points, right? That what is the expected time for me to reach point A and point B. Another functional requirement could be like this application should be pluggable, right? You could easily, like you should be able to plug data like the traffic data or weather data, right? That should be pluggable. Or say data on road closure or accidents, things like that. Okay. Are you getting it? What do I mean by functional requirement? Right. So there could be more, but for beginner, I think 3 functional requirements would be good. First, identifying the route and whatever, basically just the route, okay, between A to B. What are the possible routes? The second could be ETA. Okay, it should tell you the ETA. And the third should be that it should be pluggable. It should be able to plug traffic data, or it should be able to plug weather information, or it should be able to plug road closure information or accident information, right? The entire application in general should be pluggable. Is it clear? Yes, like I said, there could be more. I am just mentioning the basics. Okay. No, Sana, plug doesn't mean update on the fly. It means like adding something later. Okay. Like you have plugins, right? You have an application and then you have got application plugins. These are some extended features of your application, like some code is there, you could just use it, and right, that is what it is. Okay. Now, non-functional requirement. Non-functional requirement are like features which you are not expecting, okay, or features which you are not telling. So for example, Google Map. Okay. So for that, availability, that it should be always available, right? Aisa to nahi ki, like say after 6 p.m. it is not telling you routes. That is not right. Okay. So it should always be available. Non-functional requirements are like, it is a requirement, but it is not a feature. It is the basic thing. Okay. That is the least that can be there. Clear? What is non-functional requirement? All right. So one thing could be availability, right? Say you are following Google Maps and it is telling you the location between point A and point B. You are following the navigation of the Google Map and suddenly Google Map stops. It's not giving you any location and you are stuck in the middle of nowhere, right? That could be a very bad situation. So that is one thing, that it should be highly available. The availability should be there. The another thing is scalability, right? Google Maps should be able to add new places. Like every time new places are being discovered, the city is being extended, right? So the map should be scalable. Another thing is that accuracy. The accuracy should be good. I'm not telling that the accuracy should be perfect. Okay. Say it tells you that the expected time is 20 minutes. You will need 20 minutes to reach some place. Now, if you if you take 21 minutes, 22 minutes, that's fine. Okay. But if you take 1 hour, 20 minutes, that is not good, right? So accuracy should be good. All right. And okay. And the final is low latency. What it means by low latency is that, say you are searching for something, you should, the result should not take a lot of time to show. Okay. So say you want to search for a route between point A and point B. You added your source, you added your destination, and you hit enter. And it takes, say, 1 second or 2 seconds. That is still fine. 2 seconds is still a lot, but chilo, 2 seconds is still fine, right? But if it starts taking 15, 20 seconds, that is incorrect, right? That is very bad design. That means that there is some problem with how you have designed your application, because of which it is taking so much time in giving the result. Okay. Clear? Clear about functional requirements and non-functional requirements? Okay, we'll come to this part later. Before that, there are a bunch of notes that I had created, and I just want to, pick up those topics. Now, a very important thing is that how Google Map, so this is real, okay? This I'm not making up and telling. So I'm telling how Google Map gets this data, right? Anybody? What do you think? How Google Map gets a data? Like say point A and point B. How will Google Map know what is the route between it? So you guys are correct. So see, there are, for very starters, there was like Google requested data from government. All right. So that what are the routes that you have, the different roads that you are having. So all the road data was taken from government. A lot of surveys were done to build the entire database. In addition to that, there were also organic data that was being added. So say a user is traveling on a road which is unidentified by Google or which is unknown by Google. Google Map did not know of that road. Okay. And if the user landed at, so let's say, okay, let me just reload it. Yeah. So what I'm telling is that this is point A, this is point B. Okay. And to go from point A to point B, there are two routes. Either you can go like this, or another route is you can go like this. Okay. There are two routes, R1, R2. Now there is a user over here. The user starts from point A, the user ends at point B, and user takes some other route. Got it? So this is also one way of Google adding data to its database. Okay. And so this route is also going to be added. A, B. So now in Google system, between 2 points A and B, it is going to have 3 routes. Okay, route 1, route 2, and the new route 3. Okay. Clear? No, Avnish. Google Map will not always pick the shortest distance, right? There are a lot of things. So say R1 is shortest. Let's say, okay. But there is road closure over here. Will this road be suggested to you? Will this road be suggested? This R1 is the shortest, but this won't be suggested, right? So in that case, Google will either suggest R3 or R2. So for Google Map to suggest alternate routes, it should also store alternate routes, right? Then only it will be able to suggest alternate routes, right? Okay. So this is how the entire data gets collected. Clear? There are surveys, government data is taken, organic data is added for some real-time users. Okay. We'll come to it. We'll come to the questions that you are having. Yeah, Preeti, of course, Google Map will not know about any construction work that is happening. So say you are extending the gate of your house, and for that you have blocked the road. Okay, you have put a lot of construction item on the road and you have blocked the road. How will Google know about it? Google Map will not know about it, right? How Google Map gets this data of road closure or anything? Somebody updates it. So there is some user. The user sees ki acha yahan pe the road is blocked, so user is going to update it. When you use Google Map, you also get that option, right? To add a accident or add a roadblock, add road closure. So that is how these things. Get updated. All right. Okay. Now, see, these are different ways, okay, in which Google Map accumulates data. So it is through data, like these are the data sources. So either it is through satellite, okay, there is crowdsourcing, taking feedback from the like general public. I don't know if you guys remember or not, but in 2005 or 6, a lot of people used to come and they used to ask questions about these roads and all, right? So they were collecting data for Google and crowdsourcing, aerial view, and yeah, okay. So these are some of the data sources for Google. All right. Now with this, what Google does is that all of this data is stored in a NoSQL database. Now, for people who do not come from a technical background, NoSQL database is, think of it like a storage of your data. But when you have got a lot of data to be stored, you store it in a NoSQL way. Okay. Clear? Right? Okay. Now, what happens is that, say user is requesting some location, or let's talk about it like this. Okay. Say you have Google Map installed on your phone. Okay. So Google will be constantly pinging the location service from your phone, which means that your location will constantly be tracked. Okay. That is how you get that. You remember I was telling you that it tells you this is your March timeline, this is your February timeline. How does Google know about it? Because your location is being tracked. Okay, where you're going, that is being tracked by Google. So the entire earth, okay, the entire earth, if you would have studied in geography, has a lot of latitudes and longitudes running around it. Okay. So These are longitudes. These are latitudes. Right? And say you want to know ki this point or any point. Okay, what I basically am trying to tell you is that every point on Earth has got a lat long value. It's called a lat long value. It means that what is the latitude of this place, what is the longitude of that place. If we talk in terms of coordinate geometry, it basically tells the x coordinate and y coordinate. Okay, you can identify any point in space if you're given the x coordinate and y coordinate, right? Talking about coordinate geometry, right? You can identify. Okay. Similarly, points on Earth are called to have a lat long value. So what is lat long value? Lat over here stands for latitude. Long over here stands for longitude. Okay. So every point is going to have these things. Okay. Lat long value. Now say you are at this point. Okay. You are at this point. And Google is using the location service. There is another service called location service. It's too technical to delve very deep into it, but it is just a service which keeps on collecting information about the user location. All right. So this location service is going to keep fetching the coordinates, the lat long value of your position, and it is going to give it to Google Maps. Okay. Now Google Maps uses a lot of systems to store and process data like Redis, Cassandra, Kafka. Okay. Like a lot of technologies. So basically it uses some technologies to store your data. Okay, so these things will be stored by Google Map. And that is why, say you have to go from A to B, okay, and you are taking route 2. Now you're following the route till here, you're going, and then suddenly you divert. So doesn't Google tell you, right? You get that option, right? Clear? Say if you divert from the route that you were following. So there are two options. Either it will not okay, yeah. So what happens is that either it will update the route. It will say ki, like if you have come till here, then follow say route 4, do this. Or it will show you some U-turn kind of thing so that you can go back to the original route. So how does Google Map know that you have diverted? Because every time, all right, every time your location is being tracked. Okay. So this is what it means over here. That user sends the location. It's not, so see, explicitly, you're not sending the location to Google Map, right? It's being tracked automatically. Okay. Now there is a load balancer in between. So of course, Google Map application is running on a lot of servers. It needs load balancers for proper performance so that the entire data and all the requests are not going to one server. To avoid that, okay, Google Map uses this load balancer. Any system uses load balancer. Okay, this is very important. Clear till here? This aspect clear? What I mean by user sends location. So user is not explicitly sending the location. This part clear from user sends location to load balancer to server? Right? Now, in this NoSQL database, I already told you, right, that from these data source, the data is there, right? That what is the route between point A to point B. Now, this server uses this database to fetch those route values. So say if the server is fetching the route between A to B, how many routes the server is going to get? Anybody? If the server is trying to fetch the route between A and B, how many routes the server is going to get? All right, correct. So what will happen? Let's consider that route 4 is also there. Okay, so it's going to get 4 routes. All right. Now, what Google Map does is that it uses an algorithm called Dijkstra's algorithm. And basically what this algorithm does is that it helps you in finding the shortest distance between 2 points. All right. So say for these two, there are like so many ways to reach A and B. All right. So using this algorithm, you find that what is the shortest distance. Basically, all of this information, okay, the 2 points are stored in a data structure which is called graph. Okay, it is stored in a directed weighted graph. Let me write over here. Directed weighted graph. All of this data is stored over here. Okay. Now, not important this right now for beginners, but yeah, okay. So what I'm trying to say is that all of this data is there. Now, Google Maps server, it uses, say, if you're not able to memorize this, the name of the algorithm, okay, forget about it. It uses some algorithm to figure out which is the best route, okay, to go from point A to point B. Now, notice over here, I'm not telling which is the fastest route or which is the shortest route. I'm not telling that. I'm telling which is the best route. Okay. So Google will always tell you the best route to go. So it will figure that out. Okay. Now, if you see over here, you can totally avoid these things, vectorization of object. That is slightly high level for you right now. Basically, what happens is that from entire data, this data is there, right? This data from satellite, cloud sourcing, aerial view, the data is there. The entire images process and everything. So you get the entire map view, right? Here is the road, here is like this is the direction that you are proceeding in, here is a closure, whatever. All right. So it gives you the map view. And all of this is there with the server. Everything is there with the server. Now the server uses Dijkstra's algorithm, or it can use Bellman-Ford algorithm to find out the best route, okay? And with the best route, because of that, it sends the ETA to the user. Now, in finding the best route, a lot of things are considered, okay? So say finding the traffic. The server or your app can use traffic service to find how is the traffic like, okay? So things like traffic are not quantifiable. Like for temperature, you can say it is 33 degree. But for traffic, you cannot say that, right? Can you say ki 3 traffic is there or 5 traffic is there? You cannot do that, right? So traffic service, it uses qualitative measures of traffic, like high, medium, low, things like that, okay? So it will use traffic service. It will use the weather service, okay, to find out. Because this traffic, weather, a lot of things are interrelated in finding your ETA, right? So for example, there is, say it is very hot. It is extremely, extremely hot, okay? Now in that case, or it's raining very heavily. In both of these cases, people who would otherwise walk or people who would otherwise take a two-wheeler will now take a four-wheeler, right? And that will increase your traffic. So I'm not telling that it will increase the traffic by 5% or it will increase your speed, it will increase your time by 10%, not quantifying that. There is a proper logic that goes behind calculating these values. All that I'm telling is that these are different things on which server relies on in calculating the ETA, and that is how the server sends the ETA to the user. Clear? All right. This is how a very high level design. So this is a very high level design, okay, of Google Map. Is it clear? Now, this is just, more example into it. So this is little bit more detailed. So say there is a mobile user, okay? So in mobile user, you see a tile, right? You see a tile on your map. What is that tile? That tile is nothing but like one square, okay? If you zoom in, you get in more details, okay? So all that detail is not stored on your application. It is there on cloud, okay? I'm not talking about CDN and all of that, object storage and all that. That will be slightly more complicated. Just think of that. All these information is there somewhere on the server. The moment you zoom in, okay, you will see more tiles. So those tiles are fetched in. Okay, the moment you zoom out, you want to, so say you zoom out to see the entire map of country. Okay, that is yet another, like some tiles are downloaded. Okay, this I'm talking about this part, what is meant by download of tiles. Okay, now there is load balancer, there are these services, same as what we already did. Okay, this may slightly confuse you. That is why I explained this part much in detail. And this is how the design looks like. Okay, is it making sense? Okay, good. All right. Now let's talk about the technologies that are used in building Google Maps. Okay. So, so I'll group the technologies. Okay. So, Kafka and Cassandra. All right. Both of these are mostly used for data processing. Okay, and all of that. Uh, the usage is slightly different. I cannot go into detail of why everything over here is being used, but because that will, extend the time of this class, and that is outside the scope. But these are the technologies which are behind building Google Maps. All right. And it's not important that you know all of these technologies. It's not like that. Okay. Say I've worked with Kafka, but I do not know 100% of Kafka. That is how this industry works. You do not need to know 100% of everything. All right. You just need to know that if this is the situation, what all options you're having and what all can you use. As far as you know that, you're good to go. All right. Just know what are these different things used for. Now, not spending a lot of time on technology, okay, but just giving you like these are the list of technologies that are used when building Google, like used by Google Maps. Okay. Now, how industry is utilizing Google Map. So over here, so when this presentation will be shared with you, you can do a more detailed view of this presentation. You can understand what, like, you can read this theory. I'm not spending a lot of time on theory. um, I actually want to talk a little bit more about this, how industry is utilizing it. Okay. So for example, let's take example of Uber. So do you think Uber would have created its own mapping system? Uber would be having its own satellite, right? So what Uber does is that it would be using this map APIs, okay, Google Map APIs. Similarly, Zomato, Swiggy, Blinkit, Big Basket, all of these, like there's so many things, so many applications which are using these Google Maps, right? So I'm not going over here like through this written list because of course you can do it on your own. It's just theory. You can definitely do that. But I just want to tell you, I just want to give you a few examples from your real life, okay? We have a quiz after this, all right? But this was about Google Map system design in general. Did you gain some clarity on this? So see, of course, I'll be very honest, after this lecture, it's not like you will be able to do system design, you will go and you will design any system. It's not like that. The agenda was for you to understand what a system design, why is it used for, what are the components of it, and just take an example of Google Map to give you a detailed look into it, that how data is being stored, how the best route is being found out, what algorithms are being used, what things are being tracked by the user, and all of that. Okay. All right. Now, before we move on to quiz, okay, there is one just an interesting thing that I wanted to share. It's totally unrelated, like not totally unrelated, but it is not very much related to system design. Okay. But I just wanted to share that because we were talking about Google Maps. So all of you know that on Earth, there is a lot of disputed land, right? Any example of disputed land? Any example of disputed land that you could think of? Right. Okay. Say Jammu and Kashmir. So, like my drawing is very bad, so I won't be able to make it properly. But say this is like that part, okay? Jammu and Kashmir. Now, this is a very disputed piece of land, right? Because Pakistan claims that this comes under their territory. China claims some part of it comes under their territory. And India claims some part of it comes under their territory. Okay. Now, if you see Google Maps, so when you zoom out, you would be seeing Google Map makes the boundary also. So it will make the boundary of states with dotted lines, or it will make the boundary of country with dotted lines. Have you seen these things? Right? So now it is a very tricky thing for Google Map to figure out that what should be the exact boundary, right? The countries itself are not able to come to a common conclusion that what is the proper boundary. So how can Google Map come up with this? All of you are understanding the ambiguity in the situation, right? And Google Map can also say, Google Map says that this entire part belongs to India, right? Say that Google Maps puts the entire Jammu Kashmir under the dotted lines of India, right? Now, 1/3 of world's population comes from Pakistan, India, and China. Now, do you think that that will be a very big loss for Google? Do you think that will be a loss if Google says that this like marks this as belonging to India? There would be ambush from people belonging to Pakistan, from people belonging to China who are using the application, right? They would not like it. Any guesses how Google solves this problem? Google still shows the boundary, right? Google has to show the boundary. It cannot not show the boundary. It needs to show the boundary. Any guesses how Google fixes this? Very good, right? That is how it works, okay? If you are from India and you are searching, so it will show you that these things belong to India, okay? If you are from Pakistan, you are searching, so it will show that the disputed land belongs to Pakistan because that is what Pakistan believes, or that is what India believes, right? Ki this land belongs to us. So that is what it will show. If there is a person searching from China, so Google Map will show that that piece of land belongs to China because that is what people over there believe, right? So this is not related to system design. This was just a fun fact about Google Maps because we were talking about it. Okay. I hope you guys found this class useful. All right. So let's have just a second. Let's start with quiz. Can all of you go to kahoot.it? And guys, please fill the Google form. Okay, you would have received a Google form for feedback. Please fill the Google form. Please fill this form. Okay. And please navigate to just a second. Kahoot.it. We are just going to have a very quick quiz. And I'm giving you the game pin. This is the game pin. 95556. Please enter this game pin. Just go to kahoot.it, guys. CAHOOT.it. Let me share this link. Okay, this is the link. Go to that link and add this game pin. Quickly, I want all of you over here. Giving you guys 1 minute to join. Let me, just a second, I'll share my screen with the computer audio. Okay, is anybody still joining? Should we wait or we can proceed? Are we waiting for anybody to join or we can proceed? Guys, the quiz link is just kahoot.it. Go to kahoot.it and add this game pin over there. All right, are we good to begin or should we wait? Guys, the top 3 people are like, there is something special for you 3. So please quickly join. Okay. I guess we are good to start. All right, you have to be correct and quick, okay? That is how you'll come on the leaderboard. Here comes the first question. Which of the following is not a feature of Google Map? Focus on the word not, okay? It is not talking about the feature. What is not a feature? Real-time traffic information, built-in messaging platform, turn-by-turn navigation, street view imagery. Do not put the answers over here in the chat. You have to answer over there on Kahoot. Correct. Very good. Built-in messaging platform. Okay. Now let's see the leaderboard. That's how the leaderboard looks like right now. But this was just the first question. 4 more questions remaining. Anything can happen. So yeah. What is the primary purpose of load balancer? We have just discussed this. Store data in distributed manner, handle server-side logic and processing, distribute incoming network traffic evenly across multiple servers, provide user authentication and authorization. Five seconds remaining. Correct, right? This is what it is. Distribute the incoming traffic evenly across multiple servers. You remember I was giving you that example, right? So say there are 100 requests, you have got 5 servers. So if you send all those 500 requests to the first server, what will happen, right? So yeah, this is how the leaderboard looks right now. That is what I was telling you. It can change. Three more questions. What algorithm does Google Map use for the shortest route between 2 points? Dijkstra's algorithm, breadth first search, A-star algorithm, depth first search. Very good. It's this, right? Let's see the leaderboard now. Okay, so Dheera has held the first position pretty tight. Now, what is the primary difference between high level and low level system design? Difference in components, difference in architecture, difference in detail, or difference in language? Ten seconds remaining. Correct. It's difference in detail, right? High level architecture is a higher picture. Okay, it is a bigger picture. Low level architecture is the more intricate of that higher level picture, right? Higher level design. It's more detailed. This is how the scoreboard looks like right now. This is the final question, final chance to come on the leaderboard. What technology does Google Map use to render objects in the map? Five seconds to go. Correct. Computer vision and machine learning algorithms. All right. So let's see how the final leaderboard looks like. On the third position, we have Sharad. Second position, we have Yogesh. And first position, we have Rishabh. Congratulations, everybody, and to the runners-up as well. I guess it's Sandeep and Prasad. Congratulations, everybody. And yeah, I hope this session was helpful. All of you, make sure to give the feedback. And this was all that I had to share. Over to you, Rashmi.
Yes, thank you so much, Soumya, for conducting such an insightful session. I hope everyone enjoyed it thoroughly, and I was personally very intrigued in by understanding how Google has designed its system and how accurately it is able to give us the search results. And also it was very unique to understand that Google shows different territory in different countries, Kashmir is part of India for Indians and Kashmir is part of Pakistan for Pakistanis.
Yeah.
So, yeah, really intrigued with such insights. So guys, I know that it's already 10:50, so I would not be taking up much of your time. I would just be giving you a quick walkthrough of what are we trying to do at Alma Better and how are we able to transform the lives of the students. And I'll also give you a quick walkthrough of the student dashboard that you get the exposure to if you join our course at Alma Better. So please stay tuned with me for the next 10 to 15 minutes while I give you a quick walkthrough. So the session which you just attended with Soumya, so Soumya is an instructor and a part-time instructor and mentor over here. So she takes regular classes over here for the web development course. And since we already have a cohort that is coming on this Friday, that is cohort cash. So definitely if you enroll for the course, then you will keep having such more of such classes with Soumya. So yes, just give me 1 second. I'll be sharing my screen and I'll be showing you that what do we do here at Alma Better. I hope my screen is visible, guys, right? Yes. Umair, you'll definitely get the notes and you'll get the this link to this PPT after this session has ended. So please stay tuned with me for the next 10 minutes. So over here at Alma Bit, we are a community-first learning platform where students studies in groups, do projects in teams, and get ready for jobs with consultation to our industry professionals like Soumya. And we have a good pool of about 100 plus instructors and mentors who are already industry professionals, and they mentor these students and they coach these students for their learning journey step by step until they get the placements. So we already understand that since this is an completely online program, people might get demotivated. If not demotivated, then it might become strenuous for them at times to keep up with the course or to consistency with the course. So this is the reason that we provide, or we are focused on building a community first, and we call ourselves a community first platform. Everything that we do over here, or the entire course, is designed in such a way so that we put our students at the center. So every activity, or every class that, or every other thing that you do over here, you will feel that it has been designed keeping in mind that how would it help these students, or how would it be enhancing the life of our students, how would it make the journey quite easier for them to go through. So that is about it. Next, just a second. Next is the why would you be choosing Alma better? So for that, we have industry relevant curriculum, and we cover topics from basic to advanced. So for an example, like this, in this class, we covered everything from scratch, like from where Google started, from where Google Maps actually started, how did it transition its journey from 2001 to till 2023, like what all milestones is it achieved, and so on and so forth. So for every live classes that you attend, the concept would be starting from very basic levels, and then it would be advancing to the fundamental level. We have 100 plus live classes with us, and they recorded to those live classes would be there on your dashboard for a lifetime. So at any point in time, if you want to revise some concepts, or if you want to relook at some advanced concepts, you'll be having the exposure to those on your dashboard. We offer 20 plus capstone projects and 1,000 plus coding problems and assessments. So it will feel that you are engaged with something or the else for the next 6 to 8 months. You will never run out of content. You will never run out of the projects to work on. You'll always have your hands full with something or the other. We conduct weekly doubt resolution sessions, and we also give one-on-one mentorship sessions. So what does this mean is that along with you clarifying your doubts in the live classes, we will also be giving you the exposure to the doubt resolution platform, wherein you can go and you can resolve your doubts in a live class or in a live format. So there will be particular slots in which you can go and resolve your doubts. Along with that, as and when you feel, you can also book a one-on-one mentorship session with an industry expert, with an industry professional in advance from your dashboard. We also give you the exposure to 50 plus mock interviews, and you will be getting exposure to a dedicated career coach as soon as you reach our placement drive. And needless to say, we also offer you a 100% placement guarantee, and we have 500 plus hiring partners with us, through which we ensure that your placement is 100% guaranteed, and you do not have to worry about the placements. You just have to put your efforts, and you have to stay consistent in your learning journey, and the placements and everything is taken care of by the Alma Better team. So you just stay focused on your learning journey throughout. Next is the Alma Better path to success. So that is pretty straightforward, because all you need to do is that you need to sign up and enroll in our course. So sign up and enrollment requires you to pay a nominal admission fee, and we have kept that admission fee so that you stay motivated throughout the course. You stay consistent. So when you have some skin in the game, that means that if you have invested something at first, you will stay motivated to reap the benefit out of it. On the flip side, had you not invested anything in learning, like let's suppose you get the exposure to YouTube, you get the exposure to some free resources, but nobody stays consistent and motivated to go through those resources, right? Because there is nobody, or there is nothing that you have given to consume that knowledge. So it's completely up to you. It's an outbound motivation that you need to reap in order to stay consistent with something that you have not paid for. But if you make some investment, it is an inbound motivation that since you have already paid an amount, you have to reap the benefit out of it. So that is the reason that we have kept a nominal admission fee in the beginning. And this admission fee is completely refundable in nature. So as soon as you start your learning journey, You get the exposure to the Alma Beta's dashboard through which you go through the entire learning journey for the next 6 to 8 months. And throughout that learning journey, there would be 6 to 7 modules that you would be completing. And for every module, there is a competency test and a capstone project through which we assess your learning. Because without any test or without any assessment, nobody can claim that you have completed the course, or you have consumed all that was required for you to go through that learning material that was given to you. So once you complete the tests and the projects, you get certified for every module. You get certificates for every module completion. And compiling all of those 6 to 7 modules, you earn a final course completion certificate. And once you have completed the course, that is when we push you for the placement drive. That is when we welcome you for the placement drive. And in the placement drive, you need to sign an income share agreement with us. So through that income share agreement, your placement is 100% guaranteed with us. And in return, you promise to pay us only after you have gotten a placement of minimum 5 LPA. So the minimum package that we provide is of 5 LPA, but the average stands somewhere around 8 to 10 LPA. So upon signing the income share agreement with us, you get the refund of the initial admissions fee that you have deposited here at Alma Beta. So this is where you sign the income share agreement with us and get the refund of your admissions fee that was deposited earlier. And this is how we make it an effective pay after placement program. So after signing the income share agreement, you come to our placement drive, wherein you go through the placement preparation, where we conduct a lot of activities. Like you will be going through your resume building sessions, where we would be incorporating all of the projects that you have done throughout the course on your resume. You would be going through 50 plus mock interviews, and you would be again going through some revision sessions so that you can crack the coding assessments that you face in the final company interviews. So all of those things will be happening over here. And once we get a reaffirmation from your career coach or from the mentor that you are associated with your placement journey, that is when we start sharing your profile with our hiring partners, and upon which you get multiple job opportunities and you finally land a job, your dream job of minimum whatsoever package of minimum at least 5 LP. But if you are highly consistent throughout the course, then you can definitely expect a package of around 8 to 10 LPA. So that's about that. That is the a clear road to success that we offer here at Alma Beta, wherein you do not need to worry much about your career outcomes. We are there for you. Next is the learning activities that we provide over here. So for technical skills, we conduct live lectures that happens on a regular basis. It happens about 4. You will be going through at least 4 live lectures in a week, for which the schedule would be given to you in advance on your dashboard. We have multiple lab experiments. So for the topics where you find some difficulty in understanding, we have developed there is a separate platform where you can visualize some concepts. Not a separate platform, but on your dashboard itself, you'll be getting the exposure to doing things that you can see live. So let's suppose if there are some mathematical topics, if you have to do some statistics and probability, then you can actually toss the coin on the screen and you can see that what would be the outcome of the let's suppose 50 coin tosses. So concepts like those, wherein you need to have some visual idea as to what is going on in the hindsight. You'll be going through multiple projects and assessments like I already discussed, and there will be multiple group discussions. So as soon as you enroll in the course, you will be becoming a part of a group of 5 people who would be there for you throughout the entire learning journey. Next is for the motivation and industry exposure. So for that, we conduct one-on-one mentorship sessions. We also have guest lectures. So like this masterclass, we conduct multiple of such events every week, wherein you'll be getting the exposure to interacting with an industry expert. So this is a masterclass. We conduct sessions in different formats, wherein we will be conducting Ask Me Anything sessions with an industry professional. So you can go and clarify your doubts in those sessions as well. And there is community participation, wherein we conduct some events in good intervals, in small intervals. And then the last part is mandatory for Alma X. So for mandatory for Alma X, you'll be doing capstone projects and competency tests, like I already discussed. Next is that we have 500 plus companies hiring from us. So we have strengthened the bond with our hiring partners, and happy to say that we have around 600 or 600 plus hiring companies that we have partnered with. So 200 to 300 of those companies are MNCs, hundreds of those are mid-sized firms, and rest of them are startups. Next is the salary distribution of Alberta graduates. So as you can see that the minimum guarantee that we provide is of 5 LPA. So around 10% of 20% of the students fall here. But as like I was saying that the average salary is around 8 to 10 LPA. So you can see that about 2/5 of 2 out of every 5 students that is here with us gets a package of in the range of 8 to 10 LPA. Right, so this is how you can build some trust or build some faith in yourself and in us that if you are consistent throughout the course, you will be able to bag a placement, and that too a good placement. Next is the meet your instructors and mentors. So like I was saying that everybody that you interact here at Alma Mater is already an industry expert. So like we have Soumya over here with us as Soumya works at Microsoft as a senior software engineer. So we have multiple such industry professionals who are taking everyday classes at Alma Mater. So how great it would be to interact or to get some topic delivered or be taught through an industry expert. Like every topic that you'll be studying, you'll be able to see that how are they applying it in the real world, how are they making utilization of such concepts, such complex concepts in their day-to-day work life. You'll be getting some idea, you will be preparing yourself for a job from day one, not just in the placement drive. So that is what we are also trying to drive here at Alma Mater. And then the next part sorry for that. And then the next part is the success stories. So over here, you can see that there are multiple folks on this, what to say, on this poster, but definitely you would be one of them one day, like given that you start your preparation or if you start your learning journey on time, then 8 to 9 months down the line, this could be you on the poster. So definitely you can also visit our website and you can see multiple such success stories, and you can visit their LinkedIn profile as well, and you can communicate with them, and you can get some idea on how their journey at Alma Mater has been, how they were able to transform their career from zero to a hero. And it does not require for you to be from a technical background. We have been able to transform the lives of hundreds of students who came from a non-technical background or non-relevant background, and they were able to transform their journey, their career over here. And the next is the student dashboard walkthrough. So bear with me for the next, at max 5 to 7 minutes, guys. I'll be quickly wrapping this up. Let me share my screen again. I hope my screen is visible, right? So guys, just to let you know, we have a new web development batch that is coming on Friday, that is Cohort Cash. So once you enroll in the program, this is what your student dashboard would look like. This would be your home page wherein you will be seeing the, start your learning path, and then there would be free courses. So you do not have to engage yourself in these activities. Home is basically the summation of all the other separate tabs that is mentioned over here. You will need to concern yourself with the learn tab, wherein you will see like where you are in your learning journey. Let me quickly show you the classroom tab. So like, let's suppose if you enroll today or tomorrow, so this is what the dashboard would look like. So what you need to do is that you need to go to the classroom tab, and over here you will be seeing your schedule for everyday basis. Like you can see your schedule for the next 7 days or next 30 days. So the orientation of the same would happen on Friday itself. So you will be seeing this card that orientation is scheduled over here. So when you click on this join class tab, this will take you to a separate page. So we conduct classes over here at a different platform, that is AirMeet. So you will get the exposure to that right after you enroll in the program. So यहाँ से आप इस पे click करोगे join class पे, this will take you to this next grow page, and from after clicking on this join live class, this will be taking you to the AirMeet platform. And after going to the AirMeet platform, all you need to do is like you do a basic registration, and you will be able to go through the live classes. And orientation session would be the first class. So in the orientation session, you will be getting to know about the entire student dashboard in a very detailed format. I'm just giving you a quick snippet of what's coming up. So yeah, so this is for past cohort. This is for cohort Agile that was started on 14th of April. So for this, you need to go on view schedule, and from here you can just join the class. So let's suppose here that today is 26th of April. So I see that this class is going live. So I can just click on join now and attend the class. For the classes that happened in the past, I can go and see the see the lecture recording for the same. Okay, something wrong happened over here. So from the reschedule part, you can also go and review, or you can replay the lectures that have happened in the past. So you'll get the option to those over here. Or on the student dashboard as well, you will be getting an option to replay the lecture. So over here, so let's suppose you start attending the live classes and you missed out on one of the classes. Okay, so you can go ahead and replay the recording or view class recording from your dashboard itself. So all of the topics, all of the live classes that would be going on an everyday basis, you will get the schedule over here on your dashboard itself. And you can also click on view class recording and you can replay the recording of the lecture. That is as feasible and as easy as it could be. You will see that on what date this lecture was conducted, what was the topic, and who was the instructor who was taking up this lecture. This was for data science. Let me switch it to web development. So yeah, it will remain the same. That over here you will be seeing that what class is upcoming. So this class is on 26. So this is an ongoing class. So you can click on this join live class and you can go about it. On this learn tab, you will see the entire course curriculum and what is coming up for you. So this is the program orientation. This is for week 0. Next is this module 2. So this is basically module 1 because program orientation is module 0. So this is introduction to computer programming. So your entire learning journey would be going on for 6 months, and after that you will be ready for the placements. So first 6 modules are quite basic in nature, like you will be learning about JavaScript, about CSS, C++, whatsoever is relevant in the industry right now for you to become a web developer. Next is the design and analysis of algorithms. So over here you will be learning about DSA. Then you will be learning about front-end and back-end development. And after that, you will be ending it with front-end UI UX development. That is the user experience development and practical software engineering. So basically, you will be able to give yourself a title of a software engineer, even if you're not coming from an engineering background. That is the perk of having this program. So that is the certificate that you will be getting with you of a web developer, you can claim yourself to be a software engineer because you'll be having those relevant skill sets. And in today's era, that is what is needed, having skill sets more over degrees. Next up over here on your dashboard is the practice tab. So like I mentioned that you will be getting exposure to thousands of coding problems. Like you'll never run out of, you will not be able to sit idle if you are highly engaged with the course. So from here you can do multiple coding problems, coding assessments, and then quiz assessments. Next up is the project. So over here, you will be getting the exposure to multiple projects that you can put up in your profile, and some projects would be mandatory, but you will be getting the exposure to multiple projects just so that you can strengthen your skill set. Next up is the career tab. So as soon as you start completing the program, so this bar will go, this bar will start show you some completion percentage, and you will be able to have a real-time check like how far or how near you are to reaching the placement drive. And last over here on your dashboard is the mentorship tab. So from here you can book a mentorship session and you will be able to sit with a mentor and have chat about whatever topics you want to discuss. There is this my performance tab where you can have a real-time idea of how you are doing in the cohort as compared to your cohort. This is the refer and learn tab, and this is the community platform. So you will be getting, and there is also a help desk at which you can raise your doubts or queries at any point in time. It takes roughly from like few minutes to a few hours to, or few minutes to 24 hours to get back to you and to resolve your doubts. But our student support system is highly active. So for any issues or doubts you face in your learning journey, you can come over here. And to top it all off, you will be getting you'll be getting a more detailed version of this session in your orientation, like where Uma or somebody else from the learning team would be walking you through all of the key components or all of the nitty-gritty details of this dashboard. So yes, that is all that I had to share in this session. And since you guys have been so patient till the end, there is just one more reward for you. Since we are launching this batch a couple of days, in the next couple of days, there is this early bird discount of 35% that is running right now. So I want to share that coupon code with you so that you can go ahead and enroll in the course with a good discount. So just give me 1 second, guys. So this is the coupon code MAPS35 to avail an instant 35% discount on the course, and you can enroll right away. So just give me 1 second. Let me type it out for you over here on the chart. The coupon code is MAPS35. You can use this discount code and you can avail a flat 35% off. I'll just take a couple of more minutes to show you on how to do this exactly. So all you need to do is that you need to go on Alma Better's course page, and from here you need to click on this Enroll Now tab. And once you click on this Enroll Now tab, you will be redirected to the payments page. Make sure that you are on the full stack web development course. So over here, there would be a discount of 20% that is auto applied, since we are giving out 20% discount. But on top of it, you can chop off that 20% discount, and you can apply the coupon code MAPS35 and click on this apply button. So you'll get a discount of 10,500 and the final payable will come down to 19,499. And just check box these two tabs over here, and you can simply go and enroll in the course. So yeah, that is all about it, guys. Yes, so if you have any other doubts related to the course, then feel free to reach out to us at admissions@alvita.com, or you can, we have next 2 minutes, you can put your doubts on the chat itself. So you can write to us at admissions@alvita.com if you have any issues or queries related to the course, or else, yeah, definitely you can give us a call as well. There is a phone number on the bottom of the website. So yes, I believe then that is that is all, everyone. In case if none of you have any other doubts, it was great having you all here with us. See you on the other side in the next live class that we would be conducting on Friday if you enroll for the course. That is all, everyone. Thank you, everyone, for joining in. Yes, there will be prizes for the top 3 students. You'll be getting the gift vouchers. I hope that all of you have filled out the feedback form. If not, Narendra, I would request you to drop the feedback form once again on the chat so that we can provide all of you with the certificates and give the prizes to the top 3 folks. At least for the top 3 folks, I hope that you have filled out the feedback form so that we can fetch the details of you and we can get to you with your exciting gift vouchers. Yes, Nitin, actually we are, this is the maximum discount that we are giving as of now. That is the 35% discount. So this will definitely save you good amount of money. Ajay, actually there are all types of people who say all types of things. So you can only get feedback from, you have to trust your source, that whose feedback are you believing on. There would be students who might not be putting in that much of efforts and then complaining ki course acha nahi hai. But then again, you have to choose that, have you given it your all and then the course was not good, because we have been able to place more than thousands of students so far. So, and nobody can make everyone happy. So yes, that's that. You have to decide for yourself that whether you are ready to give or you're ready to be ready to stay consistent in the course or not. If you are, then definitely this is the road to success that we have designed after thousands of iterations in the past 3 years, close to 3 years, 2.5 years, I'll say. All right. Yes, absolutely. So we share your profiles, Arindam, we share your profiles at multiple companies at one point in time. So definitely you will be able to sit at multiple company placements while you are in the placement drive. All right. With that, that is all, everyone. Thank you so much for joining in. Have a very good night and a good evening. Thank you. Bye.